Welcome back. With this lecture, we will start a series on nuclear reaction. The genesis of these studies goes back to an experiment conducted by Rutherford in 1919. It is rather a simple setup. Here we have a natural alpha emitter. I think it is polonium. And through these inlets, a gas was let into the reaction chamber. That was nitrogen. There were certain other features of this experiment. For example, here, the metal foil tells what can be passed via the metal foil. It gives an indicator on the nature of emission, but that's not so critical here. And you have zinc sulfide screen. It's a detector. Okay, by this can be replaced to get an idea of the emission, and this also tells you the nature of the emission, the detector. So what Rutherford saw was that nitrogen could get converted to oxygen. This was a big deal. Okay, for many, many centuries, one of the fundamental tenet was that the nature of elements cannot be changed. So this aspect of transmutation, that is, you can mutate in the sense that the nature of the element itself can be changed, was a big leap in our understanding of reality. So that set off many other experimental and theoretical studies. So there is a notation that is used for indicating radioactive nuclear reaction. So this indicates the reactant, this indicates the products, this is indicates the alpha particle, this is part of the reactant, this is part of the products. Okay, so this is a standard notation that is used to represent this chemical nuclear reaction. So, like a chemical reaction, the nuclear reaction can also be endothermic or exothermic. There are jargons that are more typical in nuclear reactions. Endoergic. Ergy means it's typically indicative of energy. Okay. So with this word, we refer to endothermic reaction. And with this word, we refer to exothermic reaction. All right. So the main issue here is for nuclear reactions to occur, the reactants have to come fairly close to each other. Okay, so this is the distance within which nuclear modes, nuclear activity will get activated. Okay, so the distance within which chemical reactions are activated is much larger than this distance. So this is a rather small distance. Like in a chemical reaction, momentum and energy distribution occurs. And because of these redistribution, there are certain emissions. So many conservation laws are obeyed in nuclear reaction. Nuclear charge is conserved, mass number is conserved. So this is a way to balance the chemical reaction. Mass and energy are conserved. Uh, Linear momentum, angular momentum are conserved, and parity is also conserved. As opposed to all these conserved quantities, there are some quantities which are not conserved because of change in the nuclear structure. The two main quantities that are not conserved are the magnetic dipole moment, and the electrical quadrupole moment is also not conserved. This is all because of change in nuclear structure, which because of which there is no need to conserve these two quantities. So In the next lecture, we will look at some aspects of energetics of nuclear reaction. Thank you.